Lesson 10. We're going to be interpreting the graphs of proportional relationships today. So we have a situation about Grandma's special chocolate chip cookies. Okay, her recipe yields 4 dozen cookies and calls for 3 cups of flour. Using this information, we're going to complete this entire chart here. We're going to create a table comparing the amount of flour used to the amount of cookies. Now, when we're thinking about the amount of cookies, we can either think about that in dozens or the number of cookies. So if I look a little further, this does say the number of cookies. So I'm going to go ahead and change this 4 dozen to 48 cookies. All right. Create a table comparing the amount of flour used to the amount of cookies. So when I do that, I'm just going to make a simple table, and I'm going to think about cookies and flour when I do my table. Since the number of cookies I can make depends on the amount of flour I have, flour is the independent variable, so that's X, and cookies is the dependent variable, so that's Y. So I'm going to go back up here, and my flour is in cups. Just going to write that underneath, and the cookies is just cookies. Okay, so 3 cups of flour is going to give me 48 cookies, or 4 dozen. What if I doubled that, and I had 6 cups of flour? That would give me double this, so 96 cookies. What if I only had 1 cup of flour? So 48 divided by 3 is 16. What if I had no flour? No cookies. Sadness. Okay. All right. Is the number of cookies proportional to the amount of flour used? Why or why not? So if I do cookies divided by flour, I'm consistently getting 16, except here where I have 0, 0. Now, I know that the origin is part of a proportional relationship, and 0, 0 is the origin. So, is it proportional? Yes. And I'm going to say at this point, because there is a constant unit rate of 16 cookies per 1 cup of flour. Okay, what is the unit rate of cookies to flour? And what is the meaning of this in context of the problem? Okay, I think I just explained that. So I'm going to just leave that and draw a little arrow. And actually, it's good when we have the origin as part of a proportional relationship. Getting carried away with my smiley and sad faces. Okay, so now we're going to model this on a graph. So I'll talk about that a little, and then I'm going to pause it and actually make my graph. For my X axis, that'll be here. I'm going to go ahead and label that flour. And then my Y axis is going to be the cookies. So for flour, cups of flour, I only need to go up to 6, so I can count by ones here. But my cookies, I went up to 96. So I'm probably going to need to count by something larger, and I'm thinking 10 might be a good, or maybe 5. I'll either count by 5s or 10s, and I'll be right back. You go ahead and pause and label yours as well. Okay, so I labeled my x-axis by 1s and my y-axis I decided to label by 5s, and then at some point it was getting a little junky, so instead of writing 50, 55, 60, 65, I just started writing the number on every other one, just so it wasn't so junky. So my points, the first point from my table was 348. So I'm going to go to 3, let's see, we can write this here, 348. I'm going to go to 3 and then to 48, so that's right past 45, but not quite to 50. And then the next one, 696, that was if I doubled it all. 6, there's 95, 96. Then I had 116, and I had 0, 0. So I'm going to connect those points. I'm actually going to use my ruler to do that. You could use a piece of paper if you don't have a ruler at home. All right, there we go. So when I'm looking here, there's several important things happening. 0, 0 must be one of the points in order for this to be a proportional relationship. That has to be one of the points. Another thing that is happening, when you have a proportional relationship, this point 1R, that is your unit rate. In this case, it's 116, meaning there are 16 cookies per cup of flour. Okay, does it show a proportional relationship? Yes, on the graph, because when I'm looking at a graph, one, it's a straight line, one straight line, and number two, it goes through 0, 0, which is the origin. I've heard some people call it the organ. It's origin. Okay, write an equation that can be used to represent the relationship. So that equation would use my unit rate, my constant of proportionality, which is 16. So it's just y equals 16x. And it's always a good idea to label what each thing means. So this is 16 cookies per 1 cup of flour. The x was cups, number of cups of flour. And the y was total number of cookies. I wonder what your favorite cookies are. It's hard to beat a good chocolate chip. You know who makes them really good that you wouldn't think of? Subway. Okay, so there was that one. Here's the next one. Here's a graph. Oh, this is the amount of sugar. And this is by the dozen. Okay, notice this is by the dozen cookies. Okay, record the coordinates from the graph. And what do these ordered pairs represent? So we're reading the graph. Remember our title today? Interpreting. So we're reading it, figuring out what it means. Okay, so that's 0, 0. Oh my goodness, I can't read that. Counting by ones here, counting by ones there. Okay, maybe I can. 1, 2. 1, 2, 3. That's 2, 3. Okay, this one is 4, 6. Then we have, let's see, 5, 6, 7, 8, and 12. Next we have, let's see, 10, 11, 12, and 29, 18. Then this, 16 and 24. Okay, so here are the coordinates. I'm not going to rewrite them. They're here. I've chosen to write them right there on the graph. Okay, what do the ordered pairs represent? So each one is x comma y, because that's how ordered pairs work. So the x's are cups of sugar, and I shouldn't have put that. That should be a comma instead of the parentheses. So that's cups of sugar, comma, dozen cookies. So we will pick one point and just write down specifically what it means. So let's just randomly pick one. That means that 12 cups of sugar is needed for 18 dozen cookies. All right. Grandma has one remaining cup of sugar. How many dozen cookies will she be able to make? So, if she can make 2 cups of sugar, makes 3 dozen cookies. 3 divided by 2, so 3 dozen cookies divided by 2 cups of sugar is 1.5. That means that Grandma can make 1.5 dozen cookies with 1 cup of sugar. Now that point, 1, 1.5, that's 1 R, because that's my unit rate. Okay, so I'm going to go to 1, 1.5, it's right there. Unit rate, 1, 1.5. Okay, 1, R. Let's see, what else can we say about it? This is good to know. I just picked 2, 3 because, I wanted to figure out what 1 cup of sugar was, so 2 is pretty close to it. But it's important that you recognize and realize that you could have used any of these points. Since this is a proportional relationship, you could have used any of these points to find out the unit rate. And we've been doing this for quite a while. And each time I divide y by x, and I can use my calculator if I choose, but each time it comes out to be 1.5. Now, I know these facts, but if you don't, just work it out. 24 divided by 16. 18 divided by 12. 12 divided by 8. So each time it's 1.5. All right. So I just wanted to make that very clear. And then I could even add that point right here. And please note that 1.5 and 1.5 are the same. They look different, but they are the same. And you need to know that. Okay. Moving on. Let's go ahead and write an equation for this. I just feel like that's going to be helpful. Y, the dozen cookies, equals 1.5 times the cups of sugar. Okay. See, unit rate, all this works together. Okay. Oh, we didn't even need that. How many dozen cookies can Grandma make if she has no sugar? No sugar is no cookies. So that's here, that's 0, 0. It was already graphed. And we call that point O-R-I-G-I-N, origin. So, that's a fun example. It is making me a little hungry though. Oh, okay, this one's about taking a shower. So I'm looking at the graph. I'm automatically thinking, is this proportional? So I see it's a straight line. I see that it goes through the origin, proportional. And that's the first question. Wow. Yes, number 1 goes through the origin. Number 2, it is a straight line. All the things I'm looking for. How long can a person shower with 15 gallons of water? So let's look. There's 20, so 5, 10, 15, 20. Okay, these are counting by 5s. To test and make sure I know what they're counting by, I just kind of counted. I said, oh, for 0 to 20. Probably counting by 5s. So then I went 5, 10, 15, and that's 20, which it should be. So they are counting by 5s. So 15 gallons of water, 5, 10, 15 gallons is right here. 15, 5. That's 5 minutes. 5 minutes with 15 gallons, because that was 15, 5 for that point. And then the other one is going, okay, 60 gallons, so that's here. So that's 60 and 20. So 20 minutes uses 60 gallons of water. Okay, 60 gallons, 20 minutes. So I'm not sure if you've noticed or not, but I keep going back and looking and double checking myself, because with these problems, it is very simple to mess up. You have to be very precise. You have to pay attention to what you're doing and make sure that you are reading these graphs correctly. What are the coordinates of point, and that should just say A,